Excuse me. Good morning, everybody. Well, this is Mr. Aynesworth, and we're gonna get into finish our activity in financial algebra over section 4 in chapter 3 and we're gonna talk about regression today, and we're gonna do that with Desmos. So let's get started here. All right. So we're gonna start the class doing a little Q&A over homework here, and then we are going to do some regression analysis. Okay. So let's get started. Let's bring everybody in. Dun, dun, dun. Dun, 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 dun. There she is. How you doing, Jacqueline?
I'm good. How are you?
Mentally, I'm doing fine. Physically, not so good.
Oh, I'm sorry. Is it your back?
No, not my back today. It's my head. I'm coming down with a cold or something, and so I'm really congested, and I have a gnarly headache. And you know how sometimes you feel like your head's in between a vice.
Yeah.
It's and it's just so I'm not doing so great, but I'm
Okay.
powered through, and I was able to do pretty well in period one, despite the fact how I'm feeling. But mentally, I'm in good spirits though, so that's good.
As long as that is. Sorry about that. Yeah.
What
Just got
happened
over kind of being sick from a cold, and it lasted for like ever.
for you? How many days?
It was like weeks. It was probably like 2 months. I'm gonna be honest, because like I didn't give myself time to rest.
That's a problem. You
Yeah.
need, especially when you feel down, you need to have some power naps. You need to go to bed at a decent time, and if you don't do that, you're gonna elongate it. Make it longer. And
Yeah.
so I wanted to take a nap in the midday today, but guess what? It's going on midday.
I mean, we still can.
I have to meet up with a group. I've got MRWC seniors testing tomorrow, and they want an intervention today.
Hmm.
So,
I'm sorry about that.
well, got to do what you got to do, man, to
Yeah.
help people out. That's what we are paid to do, is to help kids be successful. Uh huh. That's what they say.
Is your son going back to classes or pilot lessons?
Yes,
Yeah. What days does he do it again?
it varies.
Yeah. Yeah,
I
me
don't know
too.
his schedule. He it changes, and then his work schedule at his two restaurants that he works at, Los Reyes and Yard House, uh, that varies too. So Yard House is opening back up next week. So, or no, this week. All the big restaurants are opening back up, and so he's going to start working at the Yard House next week. Los Reyes this week, and get back into work and such. Good morning, everybody. Let's turn your cameras on so I can see those smiles out there. There we go. Now I can see Mia. Mia, how you doing?
I'm good. How are you?
Doing well. Christian, how you doing?
I'm doing good. How about you?
All right. See, Adiana, how you doing there? Okay, very good. David, I have a hard time seeing you all the time, so you keep it really dark or something. How you doing, David?
I'm doing pretty good.
Well, that's good. Well, good morning, everybody. It's good to see everybody here. We are going to finish things up. I'll just put up the agenda, so take a look at that right there. It's already up on Canvas. It's on your Canvas, so I'm sure you've read it already. We're going to finish our work on section 4, and we're going to use Desmos heavily today. So you need one of these guys right here. It's called a 9 keypad keyboard. Okay, so I wouldn't suggest doing this on your phone. You're going to have to do a lot of Desmos work on regression. You're going to need a keyboard, and you're going to have to scan and submit all your work from Desmos. And so we're going to finish that up today together, obviously. We're going to do everything with you. And so please get your workbook out on section 3.4, pencil, red pen for annotating, all that kind of stuff. Get your desktop set up with your keyboard, and just get really organized here, because It's a big Desmos lesson here on regression. We're going to talk about linear regression. It's the last 3 questions in your workbook: linear, quadratic, and cubic regression. Last semester, we covered a little linear regression, but since it's probably been a couple months since we did that, we should probably review it and go through it. And then, of course, the new regression is quadratic and cubic, and so we didn't do that last semester. Thank you, Ryan. I just got your message. I know. Once in a while, if you can't have your cameras on because of a situation, I understand. Just private message me right now. But it can't be like a daily thing. You have to figure things out. And if your technology is not working for you, you need to talk to your parents because that's part of the deal. Okay, so, and Michael and Alyssa, I got your messages too. Okay, so let's get started here. Let's bring up, let's do a little Q&A first. So let me see. Be nice to see you, Maddie, Charlize, and Ashlyn and Riley. I got messages from a few others, but you guys, let me see you. You can see me, you hear me, see me every day. I would like to see you so I can get to know you guys. Okay, so start using those mics so I can hear your voices, and turn on your cameras so I can see your smiles. Okay, you guys are a good looking bunch. All right, so let me bring it up here. This is what we did on Tuesday. All right, and I asked you guys to just work on a few problems, the ones in blue, 1, 4, 5, and 6, and also 11. Okay, so you have the answers, but they're on the screen in blue. Okay, so let's do a little Q&A first on the ones that I assigned. I got it, Riley. And let's ask right now, what do you have questions on? You guys were supposed to handle a few problems between Tuesday and now. And if you need some help on anything, you got to speak up now because I'm going to be transitioning to regression here in a minute. So check numbers 1, 4, 5, and 6, or actually 1, 5, and 6, excuse me. 1, 5, and 6. The answers are up there in blue. Do you have any questions?
I did have a question on what is it, number 5? Maybe
Okay.
I think I maybe forgot to round in my previous answers, so I ended up getting 2051.79 instead of 52. So.
Oh, then you're probably, let's just check the process. A few other people want to go over number 5 as well, so let's do it. Okay. So number 5, guys, and then we'll transition to the second part here in a minute. So as we always do, let's take a look at what we have in number 5. So Ansel here wants to borrow 10,000. So we have a principal here of 10,000. That's important. It's going to be a 6-year loan. So right there, let's stop right there. How many, this goes out to the class now. How many months in 6 years? Because you need to know that because this is always the exponent. How many months in 6 years? Okay, so 6 times 12 is 72 months. Okay, this is the exponent in the monthly payment formula, guys. That's why I start off with that. It's the exponent. Okay, it's n times t. Okay, t is 6 and n is 12, and n times t is the exponent in all these equations. And so that's why I always start off with that. And then right here, it says an APR of 6.35. So R is equal to 0.0635. And then you have to know your monthly payment formula. So here we go. Now this is our work we did last time. So I'm going to take this information here on number 5 and I'm going to bring it over here. So we're working on $10,000 loan. So here we go. Number 5. Okay, the monthly payment form is right above too, by the way. So here we go. So it's that 3-step process. We got to find the monthly payment, number 1. Number 2, we got to calculate the total paid. And then number 3, you subtract the principal from the total paid and you get what's called the interest or the cost of loan. It's a 3-step process through 3 steps. Okay, so here we go. Let's set it up. We start off with P, the principal. Look at the monthly payment formula is right at the top of the screen. So you always start off with the principal. In this case is 10,000. So you times by R divided by 12. So let me see, the interest rate is in number 5, it's 6.35%. So 0.0635 divided by 12 times 1 plus that. So you just repeat it. Now you take it to the 72 power, as we just talked about just a minute ago. 6-year loan is 72 months. 6 times 12 is 72. So the exponent here is 72, really important. You get that wrong on these and you're toast, okay? So, and then you need to divide that by 1 plus 0.0635, divide by 12 to the 72 power, and then don't forget the minus 1, because if you do that, it won't make any sense. Okay? No problem, Maddie. So Charlize, how are we doing so far on this? Do you understand how I'm setting up the monthly payment on this one?
Yeah, I'm good. I think I got the time wrong, but yeah.
So you're talking about the exponent, the 72?
Yeah, but I get it now.
Okay.
Thank you.
And then, so we have, I'm not going to do the decimals right now on this one, but the monthly payment is 167.39. So unless I need to, let me go back to Christian. Christian, are you coming up with 167.39? Because you were talking about rounding earlier.
Yeah, so I got 167.38. So that's where I didn't round correctly. I
Can
should
you
have
tell me
rounded
what-
to 39.
Can you tell me what the third digit is?
Third digit is 6.
Oh, that's why it's rounded up.
Yeah.
Okay, and believe it or not, 1 penny off creates your final answer is a little bit off. So that's what happened right there for you. Okay, and then
Okay.
it looks like your process has to be right. So your total paid on this problem, you got to take your monthly payment, which is 167.39, and you have to multiply it by there's 72 months. So it was times 72, whatever that may be. I don't have an answer. Let me see. Do I have an answer for that? Yeah, I do. It's $12,052.08, and then to get the interest, you just subtract the principal. So you take your total paid, your minus your principal, which is obviously 10 grand, and then you get your remaining.
This, right?
Okay,
Yeah.
which
that
is
was what I was looking at.
2,052.
Not in as much detail.
Christian,
kind
I
of
think
see
your
the search bar
your
device.
volume's on. Okay. So a few people asked for that. Are we good? Give me a thumbs up if you're good on number 5, guys. Everybody give me some feedback on the screen, please. Okay. Okay. And let's go back to the main lesson here. So any questions on 1 through 6? Any other questions that you may have?
I have a question on number 6.
Yeah.
What would 5 and 3/8% be in a decimal when you're trying to do the equation?
Good. I'm glad you asked that. So I'm going to pick up Desmos here. And so 3/8 is a decimal. If you don't know what that is, you just type in 3/8, and that's 0.375. So on this one, Mia, it says 5 3/8. So R is equal to 5 3/8%. So that's 5.375%, because I just used decimals on the 3/8, the fraction. And then what would that be as a decimal?
Would you just times that by 100, 5.375?
Divided by 100. So
Oh,
let's
divided by. Okay.
just shift the decimal 2 places left when you divide it by 100. What do you get?
0.05375.
And that's what you're going to use in your monthly payment formula.
Okay, thank you.
You're welcome. See, that's a great question right there, guys. Things like that, if you don't know what it is, you can't even get started on the problem. All right, so I'm glad Mia spoke up on that. Anything else? You got to be honest with yourself and me. Okay. All right, then let's get started here. Let's start on number 12. I know online in Canvas it says do all of them except 12, but we're doing 12, guys, because it's not that hard. So let's go for it here. It says, let's read the problem here. The JFK Federal Bank offers a $50,000 loan with an interest rate of 4.875%. So this right here, we already know the principal. This is the rate, 0.04875. You just shift the decimal 2 places left, and T right here, T is 15, okay? All right. Oh, excuse me. I disagree with that. Erase that. I didn't read it correctly. It can be paid back from over 3 to 15 years. Okay, so T is not 15. Scratch what I just said. Write the monthly payment formula. That's what we want, okay? Monthly payment formula, okay? For this situation, let T represent the number of years. Okay, so T, it's in terms of T, so write this down. In terms of T. So this one's different because it's not asking you to calculate a monthly payment because they don't give you the T value. T is any number between 3 and 5 inclusively, which means it's from 3 to 5. It could be 3, 4, 5, all the way up to 15. All right, so you want to write the formula. So what we want to do is use the process that we just illustrated just a minute ago. Okay, we have to write the monthly payment first. Okay, so let's grab the formula here. So let me write it in red. So the monthly payment formula goes like this. Principal times rate divided by 12, because it's monthly here, times 1 plus R divided by N to the NT power. All right, divided by 1 plus R divided by N to the NT power again, minus 1. There's your monthly payment formula. Right there. And well, N is 12. So let me change my N's to 12. Sorry about that. So divided by 12 here. And then this is N is 12 in this situation, guys, as you know, because there's 12 months in a year. Okay, so there's your monthly payment formula. Okay, so now what we want to do is write the monthly payment formula for this situation right here. So guys, what we want to do is we want to take the $50,000 loan and substitute in for P. Because in this situation, we want to take out a $50,000 loan, and that's the principal of the loan. And then R, we know R too. Well, that has to be substituted in for R. And then we keep it in terms of T, because we want to write a formula. So here we go. For this situation here in number 12, our formula for the monthly payment looks like $50,000 times R divided by N, but we know R now. It's 0.04875 divided by 12 for 12 months times the compound interest formula, 1 plus, again, you just repeat your decimal because you just wrote it down. And then you take that to the NT power, but in this case, N is 12, so it's to the 12T power. N is 12 in here because we're dealing monthly here. And then you have to divide that by 1 plus, again, 0.04875 divided by 12 to the 12T power, and then minus 1. So there's the formula. So if we were, let's say, in Excel, we would type that into a one of the cells in the Excel or a Google Sheet, and then we would just simply type in a value for T. So if T was 3, we'd put T in there, and out pops the monthly formula. I mean, monthly payment automatically. If T was any number from 3 to 15, you just substitute that value for T in, and it gives you the monthly payment. And this is what, when people know at banks, they have these formulas already written out. So whatever the term may be, they can calculate your monthly payment by knowing what length of loan you need. So if you want a 4-year loan, they'll put 4 in there and they'll give you the monthly payment, depending on the interest rate. And that depends on your credit. So the bank representatives have that formula at hand. They use it all the time because they they need to talk to you, the customer that goes into the bank, given an interest rate and given the term length, what would that payment be? Or if you go to a car dealership, they have all this already known. Okay, so in part B, it says write the total interest formula. This is different. Okay, so here, the total interest formula. So what we need to do is take the monthly payment formula and modify it to get the interest. So let's start off with I here. And again, this is a 3-step process. Okay, so step 1 and to get the interest is get the monthly payment. And we have the formula right here. Right here. So what I'm going to do is just bring that down here. I'm going to rewrite it. Because we need to write the second formula for the interest. Okay, so here we go. I'm just going to repeat this down here and rewrite it. So 50,000. Just go ahead and work ahead of me here. Just rewrite it, bring this formula down because we're going to need to modify it because we want to write an interest formula now. So we take the monthly payment and we do something with it because we know the 3 steps already, guys, because we did it all day on Tuesday. So just repeat this formula down here. Just bring it down. And then put parentheses around it. Okay. Now that right there, that formula represents the monthly payment. That's step 1. And as you guys know, it's 3 steps. Okay. So step 2, we have to multiply this by something to get the total paid. So what do we do with the monthly payment to get the total paid? Let's pause here and let's think about it. Use your knowledge of what we just did. We just did it over here in number 5. Step 1, we calculate the monthly payment. Look on the screen. This is step 1. Oops, step 1. Calculate the monthly payment. Step 2 is here. And then step 3 is here. So what do you do to the monthly payment to get the total paid? In general, what do you guys do? Talk to me. After you calculate any monthly payment, what do you do to get the total paid? Monthly payment times NT. Do you guys agree or disagree with that? Okay, and that happens to be right on. Now, what's N in this situation, guys? Yes, there are 12 months in a year. Okay, so here we go. Let's go back to the formula. You guys are right on. So let's go back here. Now our monthly payment is in this big expression right here, and we have to multiply it by NT or 12T. So multiply it by 12T. This right here, this big expression is the total paid. We took the monthly payment formula in black. We multiplied it by the number of months in red, which is 12T, and you get the total paid. Now, what do you do to the total paid to get to the interest? What's step 3? Do you guys agree with Maddie? Yeah, you always subtract the principal, and the principal of the loan in this case is 50,000. So go minus 50,000. And that is the formula, all right, for the interest. And if we were, let's say, on an Excel Google sheet, we would enter this crazy looking formula, even though it looks gnarly. You enter it in, and then on another cell, all we do is put a value in for T, and it will automatically calculate everything for us. And this is what people have when they go to the bank or when they go to the car dealership. They already have this on Excel spreadsheets. These formulas are already put in, and all they do is put the interest rate in and the term, which is the number of years, either 4 years, 5 years, 6-year loan, 7-year loan. Cars usually go from 4 years to 7 years, and they just put the T value in there, and they can tell you immediately how much this thing cost, for interest, or what the monthly payment would be, because they know the formulas. Okay. All right, and that's number 12. Who understood it? Who was understanding me? Who's with me today on that? Who really understand deeply on this one here? That's not bad. It might take some time to digest, especially, with formulas, but that's how you do it algebraically using a formula. Now the new stuff, 13 on, here we go. We want to do some regression. We're going to do some linear regression. Okay, that we talked about in semester 1. I forgot when, but we talked about linear regression. This table here represents a $230,000 loan at 5.5% for 20 years. But it doesn't give loan balances between the 7th and 8th year. It doesn't give information between the 9th and 10th year either, just for the whole numbers, between the 1st year, 2nd year, and so on. What happens over time? What happens over the 20 years? And so we can use linear regression or some type of regression analysis to predict what the loan balance would be between, let's say, year 12 and year 13. Let's say at year 12.5, or the halfway between the year. All right, but the question is linear regression the proper tool, or is quadratic regression the proper tool? Which one's better? Or is cubic? We're going to talk about cubic regression. Is that the best? Which regression is the best fit for the data? In fact, let's write that down. Okay, so which regression curve, I'm going to call it a curve because these are going to be curves here in a minute. So which regression curve, when that fits, okay, that's a key word. You have to understand what that means here in a minute, fits the data the best. The only way to determine that is by looking at the graph, okay? We need to graph the data and everything. So we can't answer this question until we're all done. And we will, okay? Because I'm going to go through the whole process with you right now. So Ryan, I'm going to be taking probably in most of the period here. So I'll post the recording later. And if you have to take care of a personal situation, then you do it. But I would highly suggest you watch the video, because not only is this going to be required to submit all your work, but you're going to be testing on it come Monday. So make sure you get caught up later on this evening. Okay, so let's do this. Let's get the Desmo set up. So I don't want to use the scientific, I want to use the graphing. So get this set up. In fact, so pull up this and pull up your account. I asked you guys on Tuesday to set up an account so you can save your work, and I hope to God that you did that. Okay, so this is our work from yesterday. This is everything we did. Look out, that's everything we did yesterday, Tuesday in class. And this is why I said, open up account, use your student email like I have. I put my work email on. You just set up an account, you save all your work by section, and then at the end of the chapter, you have all the things necessary to review later on when you get ready for your chapter exam later on in a week or two. Okay, now we need to do some regression. So the very first thing we do is we have to enter the data in. And that we did before last semester, but I'll refresh everything. I'll do everything with you again and step it all off for you guys, because it's been a couple months since we've done it. Okay, grab a new row here. I'm going to move mine up to the top so it's easy for you to see. You can shift the rows up and down as you see right there. To do this, I would highly suggest use your keyboard instead of the digital keypad, but whatever you want to use, I'm going to use this. And we have to enter in this table, all of us, including me. Okay, so here we go. Go hit the plus sign up there at the top, select table. And I want you to watch me just for 30 seconds here. I want to show you something cool that you saw in the Google Sheets last semester when we did some Excel spreadsheet design stuff. Desmos uses Excel within it. So it also recognizes patterns. So watch me enter the numbers in from 0 through 20. So 0, enter, 1, enter, 2, enter, 3, enter. And then it recognizes the pattern. You simply add 1. So all I have to do is press the enter button a bunch of times, and I go all the way up to 20. Okay, everybody do that. Make sure you put the 0 in. Okay, don't start at 1, start at 0. Otherwise your data is going to be off and all your numbers are going to be off. And as I do this here, if you want me to repeat anything, because you guys are trying to do things simultaneously, you're listening, typing, and doing everything simultaneously. If you need me to repeat anything, ask me immediately and don't wait, because if you get behind, then God help you. Okay. It's difficult. So ask questions frequently. Just turn on your mics and stop me immediately and ask questions. Okay, now this is where you got to be careful, because if you mess up one digit out of all these 8-digit numbers, your answers are going to be different. So here we got to go very slow and be accurate. So 230,000, enter. Just keep hitting the enter button and it'll shift down. So everybody work on your own and get these numbers in. I'm going to be doing the same thing. And usually when I do this, I look at 3 numbers at a time, and then I look at the screen and I check it, and then I move on. Okay, so just be careful in your data entry here, because like I said, 1 digit off and your numbers are not going to be the same as mine, assuming I'm correct. Okay, which hopefully, hopefully I am. I pulled it off last period. Been struggling today because I'm physically not well. I've got the gnarly headache and I'm coming down with a cold right now. So I've been struggling throughout the morning teaching, just because doing all this with a headache is not easy to do. But I'm powering through it. Okay. So take your time on this, because you guys got to get this part right. And all our Desmos work right here, we're going to print and then scan and include with our work today. So this goes with your student workbook when you submit it in Canvas to get full credit, that is, okay? You got to show me that you're working with me. Now, when you're done, I would highly suggest you do what I'm doing. I pick a few numbers at random and I double check them. So I go up here to the row 3 and I check. And so I'm going to be doing that right now. I'm just going to pick some random ones and double check my entries. Because again, if you get 1 digit off, we're not going to agree with each other. When you take your quiz on Monday and you do this on Monday, then, or actually I'm going to have it ready on Sunday. I'll give you guys more time on it. Make sure you double check your stuff before you submit your work, you know. Okay, type in ready when you're done with the data entry, and so we can go on to the next step. I'm just waiting for everybody. Okay. Here we go. All right, we need another row here. So let's go up to the top of Desmos in the upper left. I'll actually press the save button here. I always save my work as I go because you don't, if anything happens, you want to make sure you save it as you go. Hit the plus sign on the upper left, okay? And we just need another row. And I'm gonna drag this down underneath the table. Okay. You can shift your rows up and down anytime you want. All right, what we need to do first is the linear regression. But before we do that, let's go to our workbook and get out your red pen and let's write down what the regression equations look like, okay? So the first one is linear, that's first degree. So it should look like y tilde, okay? This symbol is called the tilde. So yeah, and then remember that's in the, it's in the, when we do this on the keyboard, that's in the upper left-hand corner of your keyboard. So y is that's approximately equal to symbol on your keyboard. Okay, mx plus b, because it's first degree, it's linear. So whenever you try linear regression, you use your famous slope-intercept form equation, first degree function. Quadratic is different, that's second degree. That looks like this. So y is approximately equal to ax squared, all right, plus bx plus c, your famous quadratic function, and this is second degree. You know, the question is though, is this function better than the first degree? Which one goes through the data best? We don't know yet. We have to look at the graph to determine that. And your cubic, this is third degree. So y is approximately equal to a times x cubed plus bx squared plus cx plus d. And this is third degree. Look at the exponent right there. The highest exponent is 3. So which regression model, these are called models, which regression model fits the data the best? Which one goes through all these points when we graph them? Okay, and we don't know. Not yet, because we haven't looked at the graph yet. So we got to do that. So the first thing I'm going to do is I'm going to expand this so you guys can see this better here. And we need to type in the first equation here. So go down to the second row where you have that open spot there, the open row, and let's type this in. So here we go. Now, before we type it in, look at the top of the table. The top of the table says y1, not y, but it says y1. So when you type your equation out, you got to type in y1 and then tilde, not equal sign, tilde. That's the approximation symbol in Desmos. And then you type in mx1. If you look at the top of the column up there, guys, the top of the column is x1. It's not x, it's x1. So you got to type in mx1 and then you go plus b. Believe it or not, you type in the linear function and it gives you something. It gives you these values here and these values tell you something. So I'm going to screenshot this just to bring it into my lesson here so I can talk about the values. Okay, and let's talk about the first one. So let me bring this in. Okay, so here we go. So the first one, this is our linear regression line here. Okay, so this is our slope, which we're going to substitute in. This is our y-intercept. Okay, and so this is number 13 now. Let's write it out. So we have y is approximately equal to, remember this is approximate. These are approximation tools. They're not exact tools, okay? Is equal to negative 11,308.1. So negative 11,308.1 times x. And then you substitute your b in there and your b is positive. So plus 247,674. This is your linear regression line. But does it approximate the data well? And notice that it has a negative correlation coefficient. This is called the correlation coefficient. It tells you how well it approximates the data. And do you guys know why it's negative? Big hint, look at the table. Look at the table of the loan balance here. Why do you think the correlation coefficient says this is as a negative 0.989, which is very close to -1. So it's a strong negative correlation. So strong negative correlation here. If it's close to -1, it's a strong negative. Go ahead and speak.
I was going to say because it's subtracting.
Subtracting where?
All the like the loan balance. Each year it's getting less and less.
Yes.
So,
Yes, and we call that decreasing. So you're right on, Christian, and that's why. So because it's decreasing over time, because you're paying off your loan over time, because it's decreasing, you're going to have a negative correlation. That's exactly right. So write down negative correlation here. Okay. If it was growing, which would be bad for a loan, because you don't want your loan balance to get bigger and bigger and bigger. You want it to get smaller and smaller and smaller because you're paying off a loan. But if it was getting bigger and bigger and bigger, like an investment, when you're making money, there would always be a positive correlation. But this is a decreasing trend because we're going towards zero here. And that's why you have a negative correlation coefficient. R is very close to -1, which means it's a strong negative correlation there. But is it better than quadratic? Is it better than cubic? We don't know yet. All right, so let's go to the graph and let's graph this baby. All right, now notice that we don't see any points. Why is that? Why don't we see anything here? Or is it an important reason? Look at the axes. Why can't we see any points? Come on, guys, you know.
You're zoomed in too much.
What do we have to adjust, Ashlyn?
You go to the wrench and you change the x-axis and the y-axis.
All right, give me a high five. Give me a high five. Ready? 1, 2, 3. Boom time. Okay, let's go to the wrench. Okay, and everybody write this down in your notes right now. Write down, go to the wrench and change the scale. Okay, and Jonathan, you're on the right track too. Okay, well, you're talking about the scale right there, but everybody write this down. In the upper right-hand corner, you have to adjust the scale by using the wrench. And if you hover above it, it says graph settings. So everybody do what I'm doing. The X values go from 0 to 20. So we're gonna go from 0 to 20. So change these values. Go ahead and just put the first X value to 0. And then change the next one and change it to 20. And make your step equal to 1, which means that's your increment. That's what you're counting by. 0, 1, 2, 3, all the way up to 20. And notice, look at the graph just changed. It went from 0 to 20. Now your Y values start at 0. So change it from 0. And then they're big, guys. It goes all the way up to 230,000. Okay, so change it to 230,000. And make the step 5,000. Okay, because you know what? It'd be easier to count by 5,000s from 0 to 230,000. It's easy to count by 5,000. Now, if you look at your screen, now you can see two things. You can see the points, they're dots. Okay, those are the points in the table. And then this linear purple line here that you see on the screen is your regression line. Now, it almost went through 2 points, almost. And you can tell this data here, it's curved. It's not, it doesn't line up in a straight line. So that tells you right there graphically that the linear approximation, your linear regression line is not a good line. It's not a good line of best fit because it doesn't follow the curve. It's decreasing. It's going down to the lower right. That's good. But it's not very good because the data is curved and it's not linear. So make a note on your papers right now. The linear regression line is not a very good line of best fit because it's not curved. It's straight, guys. Okay. Make notes to yourself. I mean, if we had to use this model, if we didn't know how to do quadratic and cubic regression, then we would use this. All right. But today you're going to learn how to do it because it's not that hard. So I'm going to show you what's better. Okay. So here's what's better. Let's go up to the plus sign, and we need another regression line. So select the first one here. Just drag it down underneath Y1. Okay. Okay, just drag it underneath because I want you to see linear and then quadratic and then cubic. I want you to see them all in a row. Okay, so let's type in the next one here. So I'm going to minimize this so you can see it. Okay, now look on number 14. Look in red on 14. We have to type this equation in. Okay, on number 14. So here we go, Y1. So Y1, whoops. You got to put your cursor in the right spot here. So let me start over. Type in Y1. There we go. Tilde now, not equals. When you're doing regression analysis, you always use the tilde. Now you got to type in that ax squared plus bx plus c. We're doing quadratic now. So ax1. Okay, remember that if you do ax squared, it's not going to work. You got to go ax1 and then to the second power, and then you're going to be going shift 6. The little the symbol above the 6 is called the caret. It's your exponent button. So go shift 6 and it will pop you right in the exponent right there, or you can use your digital keypad, either one. Let's square that, and then you got to get out of the exponent by using your right arrow key. That'll drop you to the side. Okay, get out of the exponent and then hit plus, and then bx1 and then plus c. You just type in your quadratic function that you learned in Algebra 1 and Algebra 2. Okay. Now I'm going to expand this so we can just see things better here. Now you'll notice that the quadratic function's in black now, at least on my computer. And you'll notice that it's a quadratic function. Look at this. You know it's a parabola. And because the parabola had the a value, it says it's -307. Parabolas that have a negative lead coefficient open down. That's why this parabola opens down. And if you zoom in here like this, you can see that it runs through more data points compared to the linear function. So right there, okay, you know it's better just graphically, just by looking, because the curve goes through the points. Who sees that? Anybody? Give me a show of hands. Who understands what I'm talking about on the graph here? So the better when the curve, regression curve, goes through the points, more and more points, it's a better approximation tool. Now, but is it better than cubic? I don't know. So let me screenshot this and let me bring this one in. Okay, so let's talk about this one now. So here we go. Now, so this is number 14. This is your quadratic one. So number 14 here, guys. So y is approximately equal to a. You take these values and you substitute them in. -307.3 roughly. So -307.3 times x squared. It says in the directions to round it to the nearest tenth. So let's just do that. Plus b over here is negative, so put a minus sign actually. So minus 5061.2 times x, and then c is positive, so plus 228,209. This is your quadratic regression line. I call it curves, and I think it makes more sense to students. Okay, so quadratic, second degree. Is this better than linear? So the way you tell that is by looking at your r squared instead of your r values. So I'm going to switch. I'm going to be talking about these values. Give me a second here. I got to reboot here. There we go. Okay. So I want you guys to look at r squared values. Compare the two. Which one is closer to the one? The one for the linear or the one for the quadratic? Which r squared value is closer to 1? Linear or quadratic? And I agree with that. Okay, so let's make a note of that. So this right here, this one is closer to 1, okay, compared to linear. All right, that means that quadratic is a better fit than linear. So this tells me that quadratic regression is better than linear regression. So I saw it on the graph, but now I can see it using the stats. So make some notes on your paper here, better than linear regression. You can see which model is better 2 different ways. You can look at r squared and compare the 2, and whichever one's closer to 1 is the better one. Or you can look at the graph and you can obviously, ask yourself which one goes through the points. The question is quadratic the best? Is it better than cubic? We don't know. We have to do it, okay? So let's go back to the graph and let's do your cubic now. So go hit the plus sign and grab another row. And I'm gonna slide it down underneath the quadratic. So just in the margin, just bring it down. And let's put in the quadratic curve, cubic curve. That's the one in green up there. Okay, so we got to type this in. So here we go. By the way, am I going, how's my speed right now? Am I going at a good speed for you guys? Not too fast, not too slow? Okay, because if I'm going too fast, you gotta let me know. I try to focus on quality of understanding versus, blasting through a lesson here, because I don't want to lose people. All right, so here we go. Let's start entering in then. We got to type in the cubic one. So here we go. Y tilde, Y1, and then tilde. And then we have to type in AX cubed. So AX1, and then we take it to the 3rd power. Make sure you type in the X1. Because if you don't, it's not going to come out right. Okay, use your right arrow key and get out of the exponent before you hit the plus sign. And then you got to type in bx1 squared. So bx1, and then take it to the 2nd power. And again, your exponent button on your keyboard is right above the number 6. It's called the hat or the caret. People call it different things. Get out of the exponent. Okay, and then add cx1. So cx1, and then add d, the constant. D is the constant. Okay, so let me expand this so you guys can see it. Now the red one on the screen is the cubic one. Okay, so let's do it graphically first. Let's figure out whether the cubic is better than the quadratic. So look on my screen because I'm going to expand it here. I'm going to zoom in. For you guys, if you don't have a touch screen, you can use the plus or minus buttons to the upper right. Okay, now when I zoom in here, just watch me first and then you can do it. And I'm looking at a portion of the graph. Look at this, I go in, really zoom in really far. Red is cubic, black is quadratic, and purple is linear. Which color goes through the points the best? Which color do you see on my screen? Now I can't see Damien, Josh, Mondo, Xavier. Are you guys good? Can you guys see this? Okay, just make sure you can. So we know cubic's better now already. If you look all along the curve, the red one, the cubic one, goes through the data points better than the quadratic. So visually, I see that. But how do you tell using the stats? So let's screenshot the cubic one. Let's talk about it. So we bring it in. Okay, and let me bring it in right here. This is number 15 now. So this is cubic. Okay, so number 15. This is cubic, third degree. So right here we have y is approximately equal to, let's just write it out first. A, which is negative 5.6. So negative 5.6. I'm rounding to the nearest tenth here because that's what it says to do in the directions. Times x cubed. B is negative, so minus 139.6 times x squared. C is negative as well, so put minus 6,470.9 times x. And then D is positive, plus 230,121. Okay, but look at the r squared value. There you go. So everything, all the results are on the screen now. So for the linear one at the top, r squared is 0.97. For the second one, the quadratic, r squared is 0.9998. For the third one, the cubic one, r squared is 1. Which one's best? Linear, quadratic, or cubic? Okay, so visually, it has to go through the points. Statistically, you want to look at r squared and make a note on your paper now. You want to always look at r squared and it needs to be close to 1 to be a good fit. Make sure you write that down. R squared needs to be close to 1 to be a good fit. In this case, it happens cubic is the winner, okay, on this one. Okay, so now, before I do the last thing that we're going to do, let's pause here and ask any questions before I do the last thing, which is a prediction here. Okay, so here's the last thing we're going to do. We're going to predict. So in the table, everybody get your eyes on the table here. We do not know what the loan balance would be at, let's say, t is equal to 15.5 years. We don't know what is it going to be. Balance equals question mark. We don't know what that is. And you can't take an average, okay, because the average only works if it's linear. Did you guys hear that? Averaging does not work because this is what? This is, average does not work or does not apply because this is not, it's not linear. What is it? This data is not linear. It is, yes, that's true, but be specific. We just talked about it. It's cubic, okay? It's cubic, believe it or not. So you can't average, cannot average, cannot average. Okay, okay, it is not linear. It is not linear data. Averaging only works if it's linear. So, all right, so how are we gonna do this? So let's go back to Desmos. Last thing we're gonna do. Here we go. We need another line here. So go to the plus sign and add another one here. Let's bring it all the way down underneath cubic one because we're going to use the cubic. So bring it down underneath the cubic because we need to write the equation of the cubic one. But this time, guys, we use equal sign, no tilde. Okay, so here we go. Watch me. We're on this one here. So y equals now. Hit that equal button. We're going to type in the cubic regression line, what we wrote down on your paper. In fact, let me minimize this. We're going to use this one right here. We got to type this guy in, but we're going to use an equal sign. All right, so negative 5.6 x cubed. Cubed, come on, Aynesworth, cubed, there we go. So just type it in, work ahead of me, get that typed in, minus the 139.6 x squared Notice I'm not using subscripts here and I'm using the equal sign, okay? And then minus 6,470, 0.9x, and then plus your constant, that big constant, 230,121. Okay, and there is your cubic line, okay? Now we want to, this is a predicting tool. You get regression lines, guys, to predict. And as I was saying earlier, what in the world is the loan balance at the 15th and a half year? I don't know. Okay, so here we go. We did this last semester, but like I said, it's been 2 months at least. So I wanted to do it again with you guys. So go to the very top. You see this gear symbol at the very top. It's called a gear symbol or a cog, C-O-G, cog. Because in clocks, they're called cogs and wheels. They're gears, okay? But if you're building clocks, that's what they call them. Click on that and notice that you now have an option on your cubic line here. You can change it to a table, you can duplicate it, or you can delete it. Don't delete it. Okay, change it to a table. Okay, click on it. Now I just transform my equation to a table and I can enter any x value I want in there. And it automatically calculates the balance for you. Now the default's -2 every time. We don't want that. We want 15.5. Look on my notes. We want to type in 15.5. So change the x value to 15.5. And it predicts that your loan balance is going to be about $75,429.45. Okay, which kind of makes sense. It's, if you look at the table, look right here. Let me highlight this. Whatever it is, it's got to be between 82,000 and 68,000 because it's decreasing over time. If you want to know what 15.75 is, like after, 15 at the 3/4 year mark at 15 years and 9 months, you type in 15.75 and it'll tell you what your loan balance is. And over time it's decreasing. So that better be a smaller value, which it is. So I'm going to grab this right here. Okay, and so what we have as a predictor, we predict that in the 15th and a half years, remember this is in years now, and this is the loan balance here, that it would be $75,429.45. Now I'm going to do one more calculation here. I'm going to put in 16. Okay, and I want you to see if you see anything weird. So type in 16. Actually, let me screenshot this and bring this one in actually. Okay. Who notices anything fishy, weird in the table? Compare the table with mine, my table that I just generated. What do you guys notice? Talk to me. What do you notice?
It doesn't match the table.
Why is that?
Um,
That goes out to everybody. Why is that? Why doesn't it perfectly match the table?
Something must be wrong with the cubic regression equation.
Not wrong. Not wrong, because the procedure's all right. And assuming I entered the data in correctly, which I think it is, because I'm comparing it to what I did before. So it's not the fact that the data input is wrong. Read what Getsy said up there. Everybody read the chat. Okay. Any type of regression, whether it's linear, quadratic, or in this case, it's cubic, it's only an approximation. It's not exact. Okay. So make a note of that on your paper. It's really important that you guys understand that. This is close. 67,911 is close to 68,000. Okay. It's close. But remember, this is only approximate. So Getsy, was right on it. This is only an approximation. Only, come on, Ezra. This is only an approximation. It's not an exact thing, okay? If I wanted exact, I would use your special, the formulas that we use in this class to calculate the exact numbers. I would not be using regression, okay? This is only to estimate and to predict, okay? But it's close, it's very close. If we wanted to get closer, maybe we might use quartic regression, 4th degree, holy cow, okay? I'm not gonna do that, but maybe we could. All right, okay, so you know how to predict. These are predictions, write down predictions here. They're not exact values. The exact values are in the table. Okay, so let's pause and reflect. Any questions on what we've done? Because we did a lot today with regression. 2 new things. We did quadratic and we did cubic regression. And we also did some prediction based upon what we saw. And you talked about how to use R squared as a measure of like which one's better. We saw it on the graph, but we also saw it in the stats. By the way, we should probably grab this too. Again, all this is included in your work. There we go. So what do you guys have any questions on anything we've done today? Because some of it was review, but some of it was new. Be honest with yourself and me. Do you have any questions on anything? Okay. All right. Then this was what I would like you guys to do today. I'd like you to scan all your work with all the Desmos work and put it in Canvas. Since we're done, theoretically, if you guys did what you had to do on the previous problems, you should all be done. So you can just scan it right now and upload, and I will grade your homework tonight after I'm done with everything. I have a intervention with MRWC today, so I'll be working with them in the afternoon. If you guys need to meet me anytime later on today, message me through Remind and I'll meet with you after my intervention with MRWC. They're testing tomorrow, so they have a big test tomorrow. So I'm meeting up with them today, but I can always meet up with you after 2:30 today when I'm done with them. If you guys need to meet with me for some reason, I'll be happy to do that. Over the weekend, if you need to meet up with me for a small session, let me know. Just give me a message through Remind. I will be publishing in Canvas a review. I'm almost done typing it up right now. When I get finished, you're gonna have a section review, sections 1 through 4 review, and a quiz that's gonna be published on Sunday. I'm gonna give you both Sunday and Monday to do your quiz because it's gonna cover 4 sections, and it's gonna be comprehensive. So I'm gonna publish it Sunday to give you a lot more time. How does that sound to you guys? Give me some feedback. How does that sound? Instead of giving it to you Monday and putting on the pressure, I'm giving it to you Sunday morning or opening it up on Sunday morning to give you 2 full days, not a certain block of time. Like you got to finish it within 2 hours. I'm taking the pressure off. Does that sound good? Okay. So when I get finished with the review, it'll probably be around 3 or 4 o'clock after I'm done with my intervention. I'll put it in Canvas and you'll have Thursday night, Friday all day, and then Saturday to do your review. It's going to be due Saturday night because the quiz is going to begin on Sunday. And it only makes sense to finish your review before the quiz, right? I mean, let's be logical here. Okay, we always review before the quiz or test, not after. So the review is going to be due Saturday night. You'll have 2.5 days to do the review, which is like 10 or 11 questions. And then we launch the quiz. And this quiz is worth a lot more than the previous 2. The previous 2 are going to be small compared to this one because this is covering 4 sections. So you really have to make it a priority. Any questions or needs on what you need to do? All right. Leave me with a big smile today. You did well today. I'm proud of you guys. All right. And you guys have a great day, good weekend, and keep looking at Canvas and I'll update it soon. So you guys take care and have a good day. Riley, are you there?
Hi, sorry. The audio's been breaking up for the past few minutes, and I wasn't sure if you ended the class or I got kicked out again.
Oh, I would never kick you out.
Oh no, my internet keeps kicking me out. I've been going in and out of class.
Oh man, I will post the video for you in case you need it, because I finished up all the Desmos work and everything. And if you missed something, Riley, I'll post that in about, well, it might be ready. The recording that I had earlier might be ready. I'll post that for you so you can take a look if you need it. And all you have to do is advance it to the second part or whatever part you missed.
All right, thank you. I think I just missed the ending. I just wanted to make sure I didn't like leave and just disappear.
Did you get, this is the culmination of everything. Did you get all of this right here?
Yeah.
Okay, then you're probably good.
All right. Thank you, Mr. Ainsworth. Have a good day.
You too. See ya.